recall how earlier we saw that the midpoint between 2 points x1, y1 and x2, y2 could be obtained by simply averaging x1 and x2, x1 plus x2 over 2, and averaging y1 and y2 to get y1 plus y2 over 2. This is the most direct way to determine the midpoint between 2 points. However, it doesn't really generalize. What if we wanted to find a point 1/3 of the way or 1/12 of the way between these 2 points? We can't just average the points. We could maybe add 11 of these and 1 of these to get 11/12 or 1/12 or whatever. But that's a lot of trouble. We want a little more direct method, and also one that'll connect to the idea of parametric equations when we get there. So let's look at the alternative method. And we kind of sketched this out before and indicated it, but let's work through the details this time, or let's see the details this time. If we draw the fundamental triangle between x1, y1 and x2, y2, of course, here's the triangle with sides x2 minus x1 and y2 minus y1. The midpoint is going to lie at a vertex of this triangle here. And this triangle is, of course, going to have half the dimensions of this triangle. Now, if it has half the dimensions of the big triangle, then this side's x2 minus x1 over 2, this side's y2 minus y1 over 2. And it turns out then that if we start at x1 and move over x2 minus x1 over 2, we end up at the point x1 plus quantity x2 minus x1 over 2. If we start at y1 and move this far, this is where we end up. So that that's an expression for the midpoint. Now, if you do the algebra on this expression here, and you should do that algebra, I think I indicated before, and you might have already done this, you will get this. Just to sketch it, you're going to put x1 over common denominator. You're going to have x1 over 2 plus x2 minus x1 over 2. Then you're going to have 2x1 plus x2 minus x1 all over 2. 2x1 minus x1 is x1, so you're going to have x1 plus x2 over 2, just like this. You can replay that as many times as you need to understand everything that I said, but if you simply sit down and do it, put this over common denominator, and follow standard procedure, you're going to end up with this. And same thing here. You're going to end up with this. Now, we said that this procedure generalizes. What if we wanted to go 2/3 of the way, or 3/4 of the way, or 11/12 of the way between the points? Or generally, we're going to let P stand for the proportion of the way from here to here that we want to go. So if we go proportion P of the distance from this point to this point, what are going to be the coordinates of the point where we end up? Well, it's not difficult to do that. P is a proportion. It's some number between 0 and 1, assumedly. The distance from here to here is x2 minus x1. So the distance from here to here, if this is the triangle whose vertex here is the point that we're looking for, it's going to be proportion P of the x2 minus x1 for the whole triangle, P times x2 minus x1. Similarly, this distance is y2 minus y1, so this distance is P times y2 minus y1. It follows that the coordinates of this point are x1 plus P times x2 minus x1, which is what we've indicated here, and y1 plus P times y2 minus y1, which is what we've indicated here. And right there is the expression.